Hello, my name is Sarah Beth Jones, and I'm going to explain the information flow through the ultrasound machine. Starting off, we have the master synchronizer. This can be seen as the brain of the machine, and it makes sure all of these components work cohesively to make the ultrasound image. From there, we have the pulsar. The pulsar creates those tiny little electrical impulses, and it is also in charge of the PRP, the PRF, and the pulse amplitude. From there, we have a beam former. Now, the beam former makes the steering and the focusing of the ultrasound beam. The steering comes from the slope of the electrical signals on that beam former, and the focus comes from a curvature of the electrical signals on that beam former. Next, we have the transmit receive switch. This is also referred to as the TR switch, and it has two parts. One being it protects the fragile receiver from electrical impulses during transmission, and it also tells the machine to either listen for echoes or to send electrical signals. From the TR switch, we have the transducer, which sends and receives those signals, and it has multiple parts. We have the wire, which connects the ultrasound system to the PZT crystal. We have the case, which protects the internal components from the external world, and it also protects the patient from internal transducer electrical signals. From there, we have the electrical shield, which prevents the intermingling of the internal electrical impulses and the external electrical impulses. From there, we have the acoustic insulator. The acoustic insulator prevents the echoing inside the transducer from affecting or interfering the internal components inside that transducer. From there, we have the backing material. This reduces ringing. And then we have the PZT, an extremely important part of the transducer. And this ultimately converts the electrical impulses into sound waves into the body, and then from sound waves back to electrical signals through a process called the piezoelectric effect. Lastly, we have the matching layer, which has 2 points, which is it protects the PZT, and it also reduces the reflection caused by impedance differences from the transducer to the skin. From the transducer, we have tissue, and I have two representations of tissue, bone and a kidney. Bone is high density, and it would show up as hyperechoic or bright on the screen, and the kidney is low density. It would show up as hypoechoic or darker on the screen. From the tissue, we have the receiver, which you can think of it as the editor of the machine. It has a few parts: amplification, brightness, overall brightness. Compensation is uniform brightness. Compression, it reduces the signal range, and it also reduces the shades of gray to around 20 for human detection. And then demodulation has two parts. One being it transforms those negative waves and it translates them into positive waves, and this is a process called rectification. And then another process is it makes a little smooth line over those bumps in a process called smoothing. Lastly, we have the reject, which basically discards the unwanted signals. From the receiver, we have the converter, which deals with analog or digital or computer data, has a few components. Pre-processing, we have analog to digital converter or A to D converter. This is pre-processing in the sense that it deals with the real life data and it transforms it into digital or computer data. From there, we have digital memory, which stores that data in a binary number, which is made up of a whole bunch of zeros and ones. From there, when it is time to then further edit it and view that information, we have the D to A converter or digital to analog converter, which then brings me to the display. The display is that analog information, and this is for our sonographers' interpretation as we scan and as we edit the images as we scan. And then from there, We have the storage, which uses a PACS system, which organizes the video and image data, which is then sent to other hospitals and doctors for further interpretation and diagnosing. And this is concluding my information flow in the ultrasound system presentation.